Good morning, students. This is epidemiology courses for medicine second year. Today we are going to see measure of association in epidemiology. You remember last time we have seen epidemiological study design, types of epidemiological study design, and at what time we are going to use different kinds like case control, uh, experimental study design, different kinds. Today we are going to see the measure of association in epidemiological studies. So have attention. If you have question, you will write me through my WhatsApp. Alright. So what is association? Association means the relationship between exposure and outcome. Outcome means the result. Exposure means to what one individual exposed. So what is the kinds of exposure is it? How much it is strong? We are going to see this one. So definition of association. Association means statistical relationship between two or more variables requiring comparing two groups, exposed versus unexposed, with outcome or with disease versus without outcome or without disease. Why do we need them? Comparison with and between population, one. Second, risk factor identification. So that's why simply to identify the risk factors, that's why we need to develop associations. So when we develop this association or when we calculate, we are going to based on a table. This table is named as 2 by 2 table. So on this 2 by 2 table, as you observe from the pictures or from your handout, there are exposed group, which is we are observe as this is a row, yes group, and a no group. A and the B here, those which are exposed, and the C and the D, which are not exposed. The other group, outcome or the disease, yes and the no. This yes downward the column, yes means A and the C. These are those which develop a disease, and the no means those which are not developing a disease. Therefore, from this 2 by 2 table, A means those exposed and which have a disease. B means those exposed and which have no disease. C, those which have disease but not exposed. D, those which have no disease, again not exposed. So from the row, A plus B means total number of individuals who are exposed. C plus D, total individuals who are not exposed. A plus C, total individual with outcome or with disease. B plus D, total individual without disease. A plus B plus C plus D means total number of the sample. Total number of the sample. So this is 2 by 2 table. Don't forget to develop this 2 by 2 table. And from this we are going to develop association, whether there is a relationship between exposure and outcome. Good. The strength of association is assessed by ratio measures and difference measures. Ratio measures means relative risk, like relative risk and odds ratio. Different measures are there again. These measures may be applied, it can be at the individual level or as a population level. So ratio measures include relative risk and odds ratio. Relative risk ratio or relative risk, it can be used for what type of study design? It can be for cohort study design, it can be for experimental study design, and mostly we call it as a direct measure of the risk. Odds ratio, mainly it is used for case control, cross-section study design again. So relative risk, when we say it compare the occurrence of disease or risk factor among two groups using ratio. It is often measured or calculated from data presented in 2 by 2 table. It indicates the likelihood of developing disease in exposed relative to non-exposed. Exposed, when we say those which is exposed to different kinds of materials or agents. Non-exposed means not exposed at all. Then we are going to compare the new occurrence incidence of the disease among exposed and non-exposed. And we are going to calculate the strength association Is there association between exposure and outcome? We are going to calculate for this relative risk again. So the 2 by 2 table is like this, like exposure group is there, outcome group is there. So simply we can say A, B, C, D. So relative risk means incidency of disease among exposed divided by incidency of disease among non-exposed. Or simply you can say risk in exposed divided by risk in unexposed. What are incidency of disease among exposed? That means from exposed, those which have a disease. Which one are exposed? A and the B. Which one have disease? A. So A divided by A and the B. This is incidency of among exposed. Divided by incidency of among non-exposed means from non-exposed, those which have disease. Which one is exposed? C and the D. Which one have disease? Which one is not exposed? C plus D. Which one is have developed disease? C. So C over disease. C over C plus D. Therefore, risk in exposed A over A plus B divided by risk in unexposed C over C plus D. This is simply calculation of relative risk. We are going to interpret it again. Once you find the value, you are going to express. So when you calculate these values, it is about division. Risk in exposed divided by risk in unexposed. Therefore, the value is all the time positive, from 0 to infinity. Relative risk is equal to 1 means there is no relation between association. There is no association between risk factor or exposed and disease. That means there is no relationship at all between the risk factor and or the disease is the same for those individuals with disease which is with risk factor and without risk factor. That means A over A plus B and C over C plus D, both of them are equal values if it is 1. If it is not 1, there is a relationship. If it is not 1 means it can be greater than 1, it can be less than 1. It is greater than 1 means there is a strong relationship between exposure and the disease. It is less than 1 means there is reciprocal. There is no relationship or the effect of exposure on the disease is positive. That means it can be used as a protective or it can be used as a treatment. That's why exposure associated with decreased disease less than 1. So we are going to give values for based on the result of the relative risks. If it is between 0 and 1.5, we call it weak association. If it is between 1.5 and 2.9, moderate association. If it is above 3, high association. Association between exposure and disease. So from this table, calculate relative risk and interpret it. The case study given from this table says, table show data from court study of oral contraceptive versus myocardial infarction. For those individuals, here now exposure is those individuals who are took oral contraceptive. The disease or outcome is developing myocardial infarction. It is a disease. Therefore, who are exposed? Here A plus B exposed 27 and 455. Total number of exposed is 482. Which were not exposed? 77 not exposed, 1831 not exposed. Total number of non-exposed 1908. Total number from this which developed disease, it is about 104. That means 27 plus 77. Those which develop no disease, 455 and 831, total of 2,286. So now from this, how can you calculate relative risk? Incidency in exposed, don't forget, divide by incidency in unexposed. Incidency in exposed means 27 divided by total exposed, A over B, that is 27 divided by 482. All over 77 divided by the total non-exposed, 1,908. Calculate this. Let me give you 1 minute. Calculate relative risk and explain or give interpretation. Good. So the result is become 1.38 something. So this means 1.4. What do you mean 1.4? It is interval between 0 and 1.5. So we say that there is a weak association. Don't forget, when we interpret relative risk, on previous slide we have said if it is between 0 and 1.5 it is weak. If it is between 1.5 and 2.9, moderate. But it is below 1.5. Therefore, there is a weak association between oral contraceptive and myocardial infarction. You are going to interpret like this one. Not only the calculation, not only the results. Is that clear? Alright. Good. The other is odds ratio. It is a direct measure of relative risk in case control study and a cross-sectional study design. So odds ratio means A over C. What is A? Those which are exposed and develop disease. What is this? C? Those which are not exposed but develop disease. So A over C. Divided by B over D. B, those individuals exposed but not disease. D, those individuals which are not exposed, again no disease. So to simplify this, when you times cross, A times D divided by B times C. This is what we call it odds ratio. Don't forget the formulas. Sorry. Therefore, the same is true to relative risk. It is a positive number from 0 to infinity. If it is 0, if it is odds risk is 1, there is no association totally between risk factor and outcome, or between exposure and that of disease. If it is not 1, not equivalent to 1, there is association. That means if it is greater than 1, a strong association between exposure and disease. If it is less than 1, the exposure is used as a treatment or a protective for that of disease. Therefore, that means it is not negative impact. It have a positive impact on the disease. So the same to relative risk. If it is from 0 to 1.5, weak. From 1.5 to 2.9, moderate. Greater than 3, high association. So from this, let's calculate the table that given you that is taken from case control study of oral contraceptive use and myocardial infarction in premenopausal female nurses. In premenopausal female nurses. So the table is already given. 2 by 2 table. A 23, B 304, C 133, D 2816. So how can you calculate odds ratio? That means A times D divided by B times C. So calculate it and interpret. Let me wait you for 1 minute. A times D, 23 times 2816 divided by B times C, B 304 times C 133. So the result is become 1.6. So how can you interpret what is the relationship between oral contraceptive and the myocardial infarction in premenopausal female nurses? Is it weak? Is it moderate? Is it strong or high? How you interpret? It is moderate relationship between oral contraceptive use and the myocardial infarction. So don't forget the interpretation again. The other is difference measures or excess risk. Different measure excess risk in a sense means simply we can say attributable risk is 1 or risk difference. It measures the association that provide information about effect of exposure or the excess risk of disease in those exposed compared with those who are not exposed. So simply attributable risk is equal to incidence among exposed minus or subtract incidence among non-exposed. So don't forget what we have said about relative risk. Incidence among exposed divided by incidence among non-exposed. But here it is about minus, not division. So there is a chance of negative here, not all the time positive. So attributable risk is used to quantify the risk of disease in exposed group that can be considered attributable to the exposure by removing the risk of disease that would have occurred anyway due to the other causes. So this is used to measure public health impacts of the disease. Calculate attributable risk for this one. Simply incidence among exposed minus incidence among non-exposed. A over A plus B minus C over C plus D. So calculate this one. 27 times to 27 divided by 482 minus 77 divided by 1908. So calculate and interpret. So it is about 0.0156 something. That means when you rotate 0.02. Simply 0.02. Attributable risk percent means simply once you find attributable risk times 100 divided by incidence among exposed. Incidence among exposed means the A over A plus B, what we have said. So 0.02 divided by A over A plus B, this means times 100. So you are going to write by percentage. So this most probably about 27% attributable risk percentage. Good. The other is population attributable risk. Population attributable risk means measures the excess risk among the general population, not individual. Among the general population, that is due to exposure of interest. So population attributable risk is equal to risk in population minus risk in unexposed, or simply attributable risk times proportion of exposed in the population. So once you calculate attributable risk, you are going to, what's expected from you is simply knowing the proportion of exposed in the population. And this is used to measure public health impacts of exposure. So it estimates the excess rate of disease in the total study population that is attributable to the exposure. For example, just calculate this given here. Attributable risk is 89 per 100,000 per year. Prevalence rate or exposure in the population, exposure of that of cigarette is 20%. So how can you calculate? Everything is given here. Attributable risk times exposed to those populations, that means those who are smoking here, 20%. So this most probably it is about, if I don't make mistake, about 70 or 71 like that percent, or 77 like that. Therefore, simply population attributable risk means attributable risk times exposed, proportion of exposed in the population. Everything is given here. So both attributable risk and population attributable risk are used to estimate the effect of disease incidency of eliminating in a given risk factor. Attributable risk estimate reduction in disease incidency only in those exposed. The difference is this one, in those exposed. But population attributable risk is in the whole population, not in those individuals who are not only exposed. This is the main people. That's why we say population event. Good. Population attributable risk percentage means once you find population attributable risk times 100 divided by incidency rate in total population. You should find. Most of the time this will be given. For example, population attributable risk 17.8. Mortality rate in the total population 24.8. So it is given 1.7, 17.8 divided by 24.8 times 100. Simply this is what we call population attributable risk percentages. Possible outcome in studying the relationship between disease and exposure are major 3. The first one, no association between exposure and the disease. Totally between the outcome and the factor, there is no relationship. That means if attributable risk is 0 and the relative risk is 1. The other, positive association between the two, between exposure and the disease. If attributable risk is greater than 0, positive, and the relative risk is greater than 1. Negative association between the two. That means the exposure is used as a treatment or protective for the disease. So this is what we call it negative association between exposure and the disease. More exposure but less disease. This is what we call it attributable risk less than 0, negative, or relative risk less than 1. That's what we call it fraction number. Alright, thank you for today. Next we will see each other with analysis of cause-effect relationship for association, the relationship between exposure and the disease, or measuring the association in epidemiology. If you have question, please don't forget to write me on WhatsApp. See you for today. Thank you very much. Bye.